Good evening. This is Dr. John Bennett, televising from dark Miami. Tonight we have the pleasure of having Jean-Michel Letennier. He's a Chief Information Officer for Atomic Information Systems. Thank you very much, Information Systems. But first, let me introduce your panel before we turn it over to Jean-Michel. Hello, Sharon.
Hello, John. My name is Saran Ishwaran, and I've known John for a couple of years. I do a combination of systems engineering and management consulting.
Okay. You're probably the person that will best understand what Jean-Michel is talking about. Hello, Marco. Could you introduce yourself, please?
Hi, good evening. My name is Marco Antonio. I'm from Bolivia. Thanks for the invitation.
Okay. You're a doctor down there, right, Marco?
Yes, I'm a doctor.
Okay. Very good. Well, anyways, okay, Jean-Michel, it's all yours.
I am the Chief Executive Officer of the company, founder and the Chief Executive Officer of the company. I've been privileged to have been introduced to a new form of database technology known as associative database technology. The creation of this technology goes back to the early 60s, the United States Air Force, United States Navy, MIT, et cetera, et cetera. It was buried for many, many years simply because the hardware was not available at the time to make it functional. That time has come and gone, and we are now reintroducing the levels of efficiency in data management available through associative technology, not available through technologies today. One of the biggest issues that all medical systems face today is the disparity, first of all, the number of different medical systems or electronic health record systems. At present, there's a count of some 900 different systems on the market globally. Interestingly enough, none of them speak, none of them can communicate with each other, so to speak. You cannot have an Epic system talk to a Allscripts system, or even an Allscripts system speak with an Allscripts system. It's just a nightmarishly expensive proposition, mostly custom coding, or if you get the opportunity, you are forced to use kind of connectware called an HL7 protocol type situation. And that is a very expensive proposition for any office, hospital, or medical system, no matter what country you live in. Atomic DB allows us the technical capability of eliminating these bottlenecks. And in doing so, allows us to aggregate, correlate, and manage events on a near real-time basis across multiple systems, or really unlimited systems, into one cohesive information bucket, if you will, that is fully inquirable, or and of course can be quantify. You can quantify actual result sets in a very quick manner without specialized tools, which is a very, very important thing. A little brief review over here of what we're doing. As I said, our two main products are Atomic DB and Atomic DB Online. The first line of, you'll see data warehousing made easy. The first idea here is to allow all medical systems in any hospital to basically, we extract the data in near real time into one system and operate in such a way that the management of the organization can get a handle of all of the data. Now, these are some of the opportunities. The data warehouse is essentially the holy grail of computer science for the last 20 years. One of the unfortunate problems of this area is that 90% of the projects fail to meet their requirements, and 50% fail, and the cost is astronomical. We are by design a data warehouse, so it is very straightforward to do, very, very simple. All right. So is a relatively mature concept, as I pointed out. Traditional databases have begun to creak under the strain of volume, velocity, variety, veracity of data being generated in today's world. We're generating something on the order of tens of exabytes every month, just in the United States and just in medical. There's no system in form of a relational database that can handle that. It's just not going to happen, mathematically impossible. So something new has to be done. Things like big data implementations such as Cloudera, Hortonworks, MapR, even with those gaining traction, they're not able to handle the amount of data on the back end. So we have in-memory approaches, which again face their own problems because you have to have the largest amount of memory in order to accomplish this. And the inability to use different data types from one system to another. One example is if you take a text file from an IBM database and you combine it with an IBM file, a data row, I should say, a column from a Microsoft database and to a MySQL, they're not the same. You have to go through an ETL process. In our world, we eliminate that bottleneck easily. Core advantages that we produce is simplified, manage, and implement big data solutions. We reduce energy consumption because we create a single instance storage solution. So by definition, we reduce storage requirements by at least 50% across the board, and considerably more when we get into larger data sets. The other issue that's really, really of concern to everyone is the security and the privacy. 30% of costs on all medical systems is related purely to security and privacy. By design, we are inherently secure and inherently private. As an associative system, if your user ID is not associated with that particular set of objects, they don't exist. There's nothing for you to hack. There's nothing for you to steal. We also create our indexes using what we call factorial encryption, basically eliminating the bottleneck, not the bottleneck, but the hole of certificates and, of course, the backdoors and all of that stuff. Using factorial encryption eliminates any possibility of anyone hacking the system. It's just not going to happen. Any mathematician will explain that to you. The other significant part is we have eliminated the query language as a whole. Now, for those of you who don't think that that's a great deal, understand something that 52 cents of every dollar spent on every application developed on the planet is related to writing SQL queries. By eliminating this process and turning it into a filtering system is what we do, single instance, so we can do filtering. We reduce application cost development by 50%, but not just the cost of development. The time to market is also reduced by half because the developers do not have to spend an inordinate amount of time trying to figure out how to get the results by writing a question. So this is kind of the big data landscape. This is some of the players, and all of these players that you see on this screen right here, every single one of them are working in the EHR medical field. Every one of them. And between them, they are costing the medical system every year some $32 billion a year in the United States alone in software upgrades and on an ongoing basis. And as a total cost, because of the actual architecture, you're talking about over $1 trillion. Well, these are some of today's database technology challenges. The systems are overly complex. The architecture is incapable of handling today's growth. Big data cannot meet or replace relational database systems. It can't. They just physically do not meet the ACID requirements. Now, in the actual physical world, what we have, for example, in large hospital campuses, you can have, well, I know one particular campus in New York that has 604 different EHRs systems. 300 happen to be from one vendor, 100 from another, but you get the point. 600 different database systems to manage the campus. It takes them 12 to 18 months to get actually any kind of answers. we can change all of that and bring it down to near real time. The data explosion, as we continue to add more compliance regulations from the government and more information from whether it's pharmaceutical, biological research, biotech research, the data continues to grow in leaps and bounds. And of course, organizing, maintaining it, and making it useful is the challenge here. Now, because of these large volumes of data, we're having to spend idiotic amounts of money on storage and on data centers. And what happens inevitably is the data gets lost. Today, if someone asks you for medical records around the United States, about 7 or 8% are wrong. Then another 7 or 8% are missing. Not that they've been stolen, simply because they've been misplaced, or they've been not backed up correctly, or any number of these things. We address these issues as well. Now, as I said, building a data warehouse is an extremely difficult exercise in present technology. Now, the other issue that comes into play is when you're deciding to upgrade from one system to another. That can literally cost a business, not just medical, but any business, a great deal of time and a great deal of effort, and lost sales or lost revenue, or lost ability to collect on due revenue, which in the case of hospitals is great, considering that basically 91% of all hospitals in the United States factor their receivables. Now, when you take that into consideration, you say, well, everybody factors. Well, you know, 91% of a $4 trillion budget, that gives you a $500 billion interest bill in the United States alone for paying interest on your money. That's literally what's happening today. So when they tell you, medical bills are through the roof, half of those bills have nothing to do with medicine. Quite literally half. Or care. It's strictly paying the banker's interest, and the insurance company is not paying you, and et cetera, and all because of technical reasons. Now, the other issue is when the hospitals that are, as I mentioned, the larger campus, if you are the CEO of that campus, and you've got 20 or 30 different buildings and up to 100 different departments, the information that you're aggregating is generally weeks, months, in some cases even years old. How can you properly manage a system when the data is just not there for you to make the proper decision? One of the major issues that comes into play in terms of the emergency rooms around the country is the ability to retrieve data in sufficiently capable or sufficiently valid time frame to be effective and help the patient. In the end, this is supposed to be the goal. Get proper medical information to the doctor, related to the patient, related to the solution, and get him well. That, in some cases, can take, hours. I've seen it take hours, I've seen it take 2 minutes, and I've seen it take 2 hours. The other issue that comes into play today, because of the compliance requirements, and because of the implementation of these disparate systems, a doctor today literally spends, for every person that comes into the emergency room, will fill out anywhere from 60 to 70 different forms. And these are all on paper, by the way. And a patient on an electronic side will go through from admittance to discharge between 4 and 10 different systems. His records will go through 4 and 10 different systems. And that, of course, is a time-consuming issue as well. Analyzing this data is next to impossible. Ad hoc reports are nearly impossible. Introducing new technologies, of course, is nearly out of the box. I mean, I can quote time and again the number of times medical institutions have tried to upgrade their systems. One of the saddest events is the Department of Veterans Affairs, or the VA as it's known in the United States. They've just invested $1.3 billion into a new EHR over the last 3 years. and it failed completely. They simply walked away from it after 5 years of work, $1.3 billion, and they said it just doesn't work. And this is just one out of hundreds of upgrades around the country that have failed, because they're essentially forklift upgrades, where we're presenting a solution that is not a forklift upgrade, it is an in parallel upgrade. So your systems continue to function, and you continue to add the components and parts and migrate as you need, when you need, without requirement to technical or financial aspects of the solution. The results of the work that exists today is essentially bad data quality. Quite literally, how many of you have been in the hospitals and get the wrong information? How many times does your bill not get, and I'm talking about the administrators now, you send out, you have a billing system, you have an operational system where you enter your data, you did this, you did that, etc. You submit it to billing, it's missing a code, it's got the wrong code, it's not the right combinations of code for that particular insurance company, the data is wrong. This is ongoing. The data cleansing process as it exists today is astronomical too, because in order to get paid, you have to clean up the mess I just mentioned. Or you can go 60, 80, 90, 120 days without getting paid. And most of the time you do not get paid at all. Most emergency rooms that in the United States do not get paid for their services. Quite literally, even though it's the law that they do give out emergency services, they lose money. The reconciliation process, as I said, is another issue that is up for the challenges. Again, disparate online transaction processes, analytical processes. One of the biggest, most effective investments that's to be out there by the government is what we call comparative analysis. You will find that there are literally billions of grants by all forms of institutions trying to accomplish comparative analysis. That is to say, the idea of taking a patient from point A to point Z through that process and understanding what was a successful process versus what was not a successful process. And that has yet to be developed into anything useful for anyone. So these are the products that we're working with right now. The service online as a service, and the enterprise edition, which will be part of our EHR offering. So some of the things that we have, okay, is basically we are not a columnar database or an in-memory database, or it is a true object-oriented persistent database, which is a major challenge to many database people to understand that that means. We claim that we are in the N-normal form. That also denotes the fact that you should understand what the forms of data normalization are. Many people do not. And I'll explain that a little bit later as well. We do not manage data structures. We actually manage the referral system. We have a single instance storage, which means we do not duplicate data in our system at all. We are data type agnostic. Now, what people don't understand about computer science is that there are only two basic data types, numeric and text. Everything else is a subset of these two. And we operate at that level. So we don't have to deal with in a binary way. So we don't have to do the ETL work or exchange transaction language, transfer language, transaction language. It depends on how you look at it. We do not use a query language, i.e. SQL. Now, it's of itself, I explained a little earlier. Data volume is not really an issue, because that's the paradigm today. Data is growing by 80% a year. Where am I going to put it? The fact of the matter is, data is words. No matter how large the data set is, these are words. We only have 1 million of them in the English language, including every medical word imaginable. There are only 1 million words. That is stored on 18 megabytes of data storage. So why are we we're multiplying the data storage trillions of times when it's not necessary. By reducing and changing the way we look at data and the way we manage data. So we don't have a big data problem. We have a data management problem. By changing the management mechanism, we are by definition a green technology. Simply by reducing storage by 50%, I mean, we're talking $1 trillion a year in oil that does not have to be bought or used. The other issue is because we are a single object, we have what we call near real-time access to all forms of information. And results is we have 4 reads for every possible query that you would run. When I say query, I say filter is the right way. Now, we can replicate our database system to over 4 billion systems in almost nearly simultaneous way, if necessary. Not that we'd ever get that large, but the mathematics are there. Realistically, we've replicated to over 1,800 systems, and again, on a delta change basis. The entire installation of Atomic DB is only about 8 megabytes at its core, about 25 megabytes with its support system. The EHR will probably be on the order of about 200 megs when we're done. The API itself only contains 7 instructions. So the entire API is about 65 pages. And we'll go through some of that as well. The security, as I said, is a multifunctional, a multi-level factorial encryption. And it is object-oriented. So if your ID happens to be an object and your object is not associated with any related data, that data simply doesn't exist. The indexes don't know where to find you. There's nowhere for you to go find it. Now, the interesting thing is that we can basically connect to every single database on the planet and extract data from it into one cohesive data source. And that's when we're going to multiple aggregation of multiple data sources into a data warehouse. We built a thing called a connectivity center. That particular piece of software is designed for industrial installations. So out of the box, we'll connect to 10 or 12 different databases, and we can schedule. We have what we call a small scheduler that allows you to extract data on a particularly scheduled basis or a particular quantity or a particular type. But when we get into large environments where we have 400, 500, 600, 1,000 databases or 1,000 file types, etc., we have the connectivity center, which is essentially a hub for scheduling all of these imports across multiple instances of Atomic DB or even a single instance if necessary. We can also apply business rules here as well. Now, the data cleansing issue is probably the 800-pound gorilla in the room. Nobody wants to admit that they have really no solution on how to clean data, except the old-fashioned way, manually. And you run one algorithm this way, then you run another algorithm, then a third, and a fourth, and a fifth, and a sixth, and a 10th, and then you combine them. And so that becomes a problem. In the Atomic DB world, we have what's called reflexive association. And only because it's associative and object-oriented can you accomplish this. You cannot do this in a row and column type solution. It's just not possible. So the idea in the end is to breaking down the silos created by essentially the technology. So the way to look at it as a socio-technology versus relational is relational has created a silo. And those silos, regardless if they're by the same vendor or by multiple vendors, form essentially a brick wall at the foundational level. Think of a basement with multiple rooms, if you will. Okay? They'll never talk to each other. You'll never get through those walls. Atomic DB is a horizontal solution, not a vertical solution. It basically acts as a blanket across all of those silos. And if I wish to connect an EHR to an accounting system, or an accounting system to an HR system, or an HR system to a manufacturing system, or manufacturing, if I want to connect them all into one, I can. If I want to break them up into certain areas, I can do that too. And all of it is dynamic. Okay. The idea behind this is to empower the communities of the world in different areas. Well, we selected EHR as the beginning and most critical need in relation to people, which is what we're focusing this on. Now, one of the interesting areas that we're talking about here is driving efficiency through integrated services, thus allowing true IoT. One of the problems with IoT is it's a great idea. It's the most wonderful idea in the world. But the existing technology today does not afford you the ability to implement IoT. IoT, by definition, is a peer-to-peer solution. It cannot be a centralized solution from a technological perspective. You can argue, or many people would like to argue that, but the truth of the matter is one device has to be able to communicate with another device without the assistance of a central location. And that technology is only available through an associative platform. You cannot get it done through a relational platform, through a Hadoop, through a Cassandra. It's just not going to work. The other issue is driving sustainable cost reduction from infrastructure optimization, simplification, efficiency, and reduction in time and human resources. That is a very big factor as well. By reducing all of these or eliminating these bottlenecks, we enable people to do a great deal more with the same amount of time and at half the cost. These are some of the value proposition areas that we're talking about. And let's just move on to, all right, let's go from peer-to-peer. We did that. Private hybrid share. Okay, well, here's again a little bit more about that. And the data quality, we'll go through this a little bit. The data quality maintained at the source. Now, this is a very critical thing. When a system is asked to upgrade, whether it's a banking system, an EHR system, or any other form of system, it's generally what we call in the industry a forklift upgrade. That is to say, we're going to build a system and then we're going to move all the data over and we're going to replace. It's basically a rip and tear. So you're tearing apart the house and you're rebuilding the house. But what do you do with the people living in the house? Now, this has happened time and time and time again in all forms of areas of business, but most especially in the medical industry. And one can be seen, this can be seen as a massive disruption to business as a hospital, but more so to actually patient care. But it also prevents the management or the doctors from taking the risk of upgrading their systems, thus being, in some cases, 20 years behind the times. Because nobody wants to take the risk of a lawsuit to upgrade their EHR. They know they're going to be out of business for weeks, months at a time. We, on the other hand, allow those existing systems to continue and function in a stable, untouched condition. We operate in parallel, aggregate the data sources. We have our own EHR that sits on top of our platform. And then it is up to the end user client to decide when, how, and who or what departments will be moving over to the new EHR. The old one stays in place until the switchover can be done in a matter of minutes and can be reversed. So the source, the data at the source is always untouched. It's never broken. And if we need to, we can actually write back to the original source from our new system. And again, this goes back to the 800-pound gorilla as we discussed. The data cleansing process here is dramatically reduced by some 90%. Now, the minimum reconciliation process, as we're talking about, since there is no ETL, there's very little loss of data. It's based on a gold copy of the data. And auditing it is simple. Now, the other issue that comes into play is the transaction process. As I mentioned before, comparative analysis requires essentially that you follow the patient from point A to point Z. You want to analyze the transactions at each and every system along the way and return a result set, if you will. I did this to patient A. He registered. He spent 15 minutes. He filled out his paperwork. He took 15 minutes more, and et cetera, and so on. And then compare that to, of course, all the way through the diagnostics, the recommendations, the results, the follow-up, et cetera. And then figure out what is the most efficient way to take care of patients in a similar condition. That's the idea. This is an example of how we function. All right, the coexistence here is Atomic DB sitting up here in the middle. We source multiple data sources on the top left corner. We bring it through our connectivity hub area, or it can go directly if we wish. We have a staging area basically that does our data cleansing. It doesn't have to be there. We do it simply because it generally is a different process and people have to evaluate data before it goes into production. And once in production, from whether you have one database or 10 or 400, you already start accomplishing the reporting, internet monitoring, business intelligence in real time on the systems that have been introduced. Let's assume application A is EHR1, application B is EHR2. We can translate them to Atomic DB, and at any point in time, we can switch them backwards and forwards because the data, as you can see here, is bidirectional. So whether I enter data here or here, the data is in both places at the same time. Basically, we eliminate system downtime, migration downtime, but more importantly, we eliminate the risk of patient error, patient failure, doctor failure, system failure, and of course, business failure. We're finding that almost 20% of hospitals in the United States are at or near bankruptcy, quite simply because they cannot get through this system. Again, another view, we pull data from a data warehouse, SQL, mainframe, files, program objects. We are, by definition, a data warehouse. That opens up a lot of avenues. Okay, that we don't need to see. Okay. All right, so that's the presentation we have there. Now, I'm going to show you a couple of ideas that we're in the process of finalizing. This would be a phase one. Phase one approach. As you can see, we have multiple hospital A, B, and C. Presently, they have each a form of Epic system, wall scripts. They can have 9 different systems here. And we use, this is the phase one approach, essentially. It's an HL7 connectivity into an Atomic DB HL7 interface. So whether it's one hospital or 10, this would be our first phase. We would first allow the systems to continue to function. We would simply extract the data. That would allow us to centralize management, centralize business intelligence, centralize the EHR, centralize billing, and any number of other activities can take place over here. Now, please understand that this is bidirectional as well. Okay. Now, the phase two approach is when we get to the point, again, same kind of design, but as you can see, what we've done here is instead installed Atomic DB at the local hospital. So what I was telling you earlier is what happens now. We have a version of Atomic DB EHR installed at the local hospital. Now we're interacting. We've removed HL7 from the equation, and therefore all the costs associated with it. So we can now interact and aggregate the data at the hospital level and then interact with it at a central management console or management warehouse. In one case, we have one client who has 400 hospitals. We are in the process of doing the first 3, as you could, that's what this diagram's about. And we are as a prototype, and we're going to do this and then add each hospital as we go along. Our projected cost savings on HL7 alone amount to almost $15 million a year between the 3 systems, the 3 hospitals. And that's just beginning. The long-term phase 3 goal of what we're looking for next year is this one. It's essentially a patient-centric EHR. Now, whether people understand this or not, the patient owns the records. It's his information, not the hospitals. The hospital's only responsible, and again, they don't want to be responsible for the patient record. Neither does any doctor, for that matter. It's a liability and insurance cost. And of course, an enormous responsibility in terms of personnel, in terms of cost, moving forward. So what we're actually, part of phase 3 here is to build a patient-centric system that'll fit either on a cell phone, laptop, tablet, even any form of device really, where the patient medical record is entirely on the device, and of course can be replicated across all these devices, or even centralized at a location that the patient requires. The hospital in turn maintains its own database of the work that it had done on that particular patient. Some of the advantages are here. The patient maintains the full record. The hospital retains the partial record, only the work that was done. And moving forward, we have the ability to create a unique patient ID globally. We have the ability to the patient maintains all records in a read-only format. So in other words, the patient cannot alter his records. It has to be a registered medical professional, registered with the state, registered with some form of government agency, indicated that he has the right to manage medical records, and not just medical records. What type of medical records? What is his specialty? If the guy's an oncologist, he shouldn't be messing around with, osteoporosis, I guess. The idea here, and again, is only authorized medical personnel, and they have read-write based on the area of expertise that they are qualified for. Again, all of this sounds far-fetched in the real world, but in our world, it's really quite simple. And again, because of association. Now, the system itself essentially has read-write, has rights on both areas, and decides based on the rules that we apply. Now, the patient profile can be replicated to multiple devices, as I pointed out. So, moving forward, we're, let me see if I can bring up one more. Yes, this eventually is what will happen. This is actually the phase 4 area. We'll be able to apply any number in a peer-to-peer basis. So not only will it be peer-to-server, but peer-to-peer, so that even doctors can exchange information if they have the rights to among their devices. These are transactions that don't necessarily need to be on a server-based system. And we can then apply any number of applications involving all forms of social media into the medical system as necessary. Training, auction, video, jobs, events, focus groups, all of this as part of the medical experience, if you will. So I'll leave it open for some questions if anybody has any.
Yes. Let me just back on the screen. Okay, very good. Thank you for an excellent presentation. Well illustrated, Jean-Michel. And I hope we get more people the next time on the panel. But Saran, do you have any comments or questions for Jean-Michel to start off? Saran, are you there? Because I have a couple of questions, Jean-Michel. You know, I'm probably like most doctors know nothing about big data, even the concept of big data. But just looking at it tonight, it just seems relatively straightforward that your system is better than what's there now. How many hospital systems are hospitals are using this system now? Do you know?
Well, the idea has been in development now for about 3 years.
Okay.
The first 6 hospitals are planned for next year.
Okay.
We're in working with hospitals in Louisiana, in Cleveland, and in Rochester, and some 23 other healthcare facilities or aftercare facilities. The idea here is to truthfully minimize costs and improve patient care. Because, as I pointed out, 20% or more of the hospitals in the United States are in bankruptcy, and they're going to go out of business. They cannot, or if they're not in bankruptcy, they're operating in such a way that is actually dangerous to the patient. Because they do not have the resources necessary, the environment is not conducive to proper care. And a lot of that is not related to the medical system.
Right.
It's not related because the doctors cost too much. It's not because the nurses are too expensive. It's not because of the pensions. It has nothing to do with this. No business in the world that operates on a profit can operate paying 25% interest on their receivables.
Yeah.
It's just impossible.
Just
and we're
real-
eliminating that factor.
John, you can get off the Hangout. Just click on the green arrow again. That takes you off the screen share so we can see your face. There you go. Well, yeah, it just seemed very straightforward to me that, hey, why don't hospitals use this? Are you getting a lot of positive feedback from people you've shown it to in hospitals?
Well, I can't explain. Well, I can talk about the Rochester hospitals and the Louisiana hospitals because they're coming out of bankruptcy. And the project is essentially based on that.
Yeah.
They are the ones that are funding the effort, and we're going to put it into production for them. Once it's there, we have about 30 or 40 other organizations, let's say, that are interested. One in particular has 400 hospitals. They've got receivables going out 180 days.
Yeah.
And you can't function that way. It's just no business can.
Yeah.
There's an issue with the insurance companies as well, who continually change the specifications for filing requirements.
Mm-hmm.
And of course, since the systems are static,
Mm-hmm.
It takes the hospital a year to catch up with the insurance company.
Mm-hmm.
In the world that we're proposing, it will take the hospital literally 30 seconds to catch up with the insurance company.
My brother works for a hospital chain called Prospect Medical out of California. They have 13 hospitals, but he's a businessman and he's just getting into working with hospitals. And he just shakes his head. He says, this is not like a business. And one of the problems he says is that there are a lot of companies that are established that don't want things to change because they're doing well. They're making a lot of money as it is now. And that anybody that tries something innovative, I'm sure you guys will probably reach the same kind of resistance. Anybody that tries to get innovative and make it more efficient, they fight.
No, absolutely. But those are few. Truthfully, when you look at it, the industry, and I'm talking about the entire industry, there are some 7,000 hospitals in the United States in total.
Yeah.
Major hospitals, about 3,500 to 3,300, and the rest are what we call smaller hospital or municipal hospitals, 75 beds and less. It's the second half of that equation that's not making any money. Those are the primary cares at the local towns, the small villages throughout the United States. Those hospitals are literally going bankrupt faster than they can open them. Yeah. And at the higher end, there's always going to be money for a Harvard Medical School. There's always going to be Harvard money for Columbia or for Johns Hopkins or Bethesda being military. There's always going to be money for these large, city representative type hospitals. They come from endowments. They come from donations. But when you go past that level, which really only represents about 5% of the industry, everything below that is suffering. Mm-hmm. Whether the patient is suffering, or whether the hospital mechanically is suffering, or whether the hospital is just breaking even. And the lower the size of the hospital, the less capable the hospital is. That's not those aren't my numbers. Those are just, they're statistical, in the AMA's own words and own numbers. I mean, you just go to the website and they'll tell you. So what we're proposing here is evening the gap a little bit. As I said, it doesn't matter if you're GE or McDonald's or the New York Mets. You cannot pay 25% of your revenue and expect to be profitable. Mm-hmm. That's just impossible. And this industry that's only one factor.
Yeah. Well, we discussed this before, and it's not proprietary information, and I don't know any more than anybody else. But Apple is a big rumor going around that Apple is going to get involved in the healthcare industry, and one thing Apple has done is hire between 60 and 70 EMR people, and also we talked about Glimpse, the program they bought that is patient-centric, and it smells like Apple's going to do something in that field. Can you comment on that?
I don't know anywhere near. I haven't investigated what Apple is looking to do or not do. More likely than not, it's rumor, and
Yeah.
but you can't really blame them if you look at their position in the world today. They're sitting on, as a company, they're sitting on huge volumes of cash. So there's very few industries that they can go into and be effective, and be productive, I should say, more than anything else, to quantify the type of investment and the Apple name. Medical field is, they're probably looking at it the same reason that we looked at it.
Mhm.
You know, our technology is homogenous. I can go into banking, I can go into insurance, I can go into compliance, we can go into anything.
Mhm.
We chose EHR quite simply for the fact it's the industry that's hurting the most. And it's
Yeah.
not just in the United States. You know, we talk about Canada having this great system. If you only knew how bad the system is in trouble. And if, you know, Mexico is no better.
Mhm.
The United States, if you go to France, if you go to London, in England, it's an absolute horror show. They just are suffering from the same problems we are here. Only they don't have to do the factoring because the government won't allow it.
Mhm.
But in our case, the government allows it because these are private institutions. So the managers do what they can do. So I suspect Apple is looking at it in much the same way, as a tremendous business opportunity as well as humanitarian opportunity.
Right.
You know, because let's be realistic, how else can you help millions of people? You're a technology company, and we realize, you and I both realize, that the technology is a mess.
Mhm.
It's just not suited for the industry.
Mhm.
So something has to change, and my suspicion is that that might be why they're looking at it. If that is the case, that's the way I would look at it.
Yeah, and it would seem to be consistent with their goals of approaching thing like the music business from a very simple, just create a device and change the music industry, just change the EMR, and you know, make inroads in the healthcare industry. It's going to be interesting, but it seems like you're doing the same thing. You know, basically the patient-centric simplification of the key system, which is the EMR.
Well, there is an issue there as well, because understand that Apple really doesn't want people's data. All right,
Mhm.
they are a technology company for all practical purposes, and to their credit, have kind of stuck to that.
Mhm.
And other companies, which will remain nameless, have basically made it their business to become of your business. And entrusting them with the medical industry is, I think, a very dangerous prospect. So if there were anybody in the field that I would trust, it would be Apple, personally. But our approach to it, I think, is not something that has come across Apple's radar yet, because I looked at it, quite honestly, personally, as I don't care what technology I use, it's not going to work.
Mhm.
So there is no point. And why build something if you know it's going to fail from the start? It's a waste of money and time. So when I discovered this technology, rediscovered, I should say, with the assistance of many friends and many associates, the two were kind of married already. We could now do anything and accomplish anything, but more importantly, we could guarantee the safety and the security of a human being's personal information. And it would be up to that human being to share, not share, partially share that information.
Mhm.
And keep in mind, 50% of the costs of this industry is trying to protect people's information.
Mhm. Yeah, that's a huge issue.
Yeah.
Sarah, do you have any questions or comments for Jean-Michel?
Yeah, so JM mentioned that, you know, EHR is not the only thing that he's working on. He's also working on a few other products that might be of interest to Allied Health still. Can you discuss that a little bit, JM?
Well, what we're working on, the patient-centric piece that we're talking about, is essentially enabling people to communicate on a peer-to-peer basis outside of simply the physical network. and a peer-to-server network, but at their discretion, not at the discretion of, you know, some, for want of a better word, oligarch, who is simply going to say, I'm going to give you the system, you're all going to use it because there's nothing else. I look at these types of approaches as, you know, it's just another person trying to take control of another group of people and take advantage of them, either on purpose, not on purpose, or through his successor. By enabling the end user, and we're talking about social media, we're talking about the peer-to-peer network, by enabling and handing control of the digital life back to the individual, that opens up a lot of doors, aside from the very simple fact that today in the world, there are about 7.3 billion people. 6.5 billion of them have cell phones. Nowhere, no time in history, in the recorded history of humankind, is that possible. You as an individual standing even on this call can pick up your phone and speak to one of 6 billion people whenever you feel like it. That has never happened, without regards of where they are on the planet. So what's happening now is that the centralized technologies cannot scale to 6 billion people. You cannot do a centrally controlled system, despite what people want to try and do. Whether, you know, there's rumors of the NSA, and there's rumors of the CIA, and there's rumors of foreign agencies keeping massive amounts of data. And it's irrelevant if they do or if they don't, because it's basically useless to them. The data will continue to grow, and the more data you add to the environment, the quicker it becomes stale, because there's always new people being added to the system, new people being removed from the system. So a centrally controlled solution is definitely not the approach. It has to be dynamic, it has to be peer-to-peer, and at the volition of the end user. That allows many, 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 many options, not the least of which is a guaranteed form of democracy.
Yeah. That's funny. Well, Jean-Michel, we're going to wrap it up here. Thank you very much for an excellent presentation. I hope you come back for many more. We're going to stop recording, but stick around. We'll chat a few minutes. Thank you for coming, Sharon.
Thank you.